Hello learners, hope you are doing well. So I welcome you all to this session where we are going to solve the previous year questions, the qualifier papers in fact, so that we get an idea and an understanding of what kind of questions can we expect and how best to prepare for such question papers. So I'm just going to give you a brief layout of what the questions are going to look like. So in the next slide, you're going to see what the next question is going to look like. So here you see that your CP question paper is going to start like this. It's going to be a continuation of your previous section, which may be any of the other three subjects of maths, English, or even statistics. And the next page is going to be that of CT. You're going to see something like this. It says SEM1 CT. Then you're going to see the number of questions that are there in the question paper, or in this section in fact, and the total marks that are going to be awarded for this section. Then you will have this first question. So these two questions, question number 1 and 2 of this section. So in this paper it is question number 36 and 37. It may be different for other papers. So you see that these two are of 0 marks. So these do not account for your marks. Okay, but be careful. It may not always be in this manner. But for this question paper, the first 2 questions were ungraded. Why? Because they just want you to understand that you understand what they're trying to say. So what they're trying to say here is that the question is that this question paper for the subject Qualifier Computational Thinking is mandatory and you have to attend all sections. So that is what they need to understand, that all questions are mandatory and there are no optional questions. So you can tick yes. Even if you tick no, there's no harm, no foul, but it's better, you understand that what they're trying to say, that yes, you understand that all questions are mandatory. Then question number 37 in this paper is also an ungraded question. What they wanted to ask is that they know that you have seen these data sets, and what they are going to ask you is do you understand that this useful data has been mentioned above? So if you have seen this, definitely you got to tick yes. Even if you tick no, there is no wrong answer. Even if you get this question wrong, it's nothing about getting it right or wrong. They just want you to understand that the useful data has been mentioned above for your reference. So having understood that, let's actually go into the questions that matter, that actually count. I know that's going to count to your final assignment score, or in fact the final qualifier score, pardon me. And here let's start with question number 38. So as you can see from the options, the right answer has already been ticked. So our motive here is not to actually solve these questions. It's in fact to understand the logic behind why an answer is picked for a particular question. So what is the logic behind getting to that answer? Not necessarily getting the answer, but what was the path taken? Why did we get to the answer? So that's what we're going to try here. So the first question, that is question number 38 of this section, what it says is match the following expressions on the left side with the appropriate values on the right side. So in the left side you have 2 equal to 2 or 2 greater than 3. So what is to be understood here is that the first thing is 2 equal to 2, which means that this is a conditional operator, which means it's going to output either true or false. So this is very easy to understand, that an equal to sign's output is either true or false. In this case we know that 2 is equal to 2, so in fact this is going to be a true. Then the next one is 2 greater than 3, but we know that 2 is not greater than 3, and again this particular operation, conditional operation, also outputs true or false, and since 2 is not greater than 3, we're going to get a false. And our next operation is the OR operator, which connects this true and false statement, but we know that a true or a false is going to give you a true. So in that case, your first option, that is A, should be going to true, which is in the right column, equivalent to this one, 2. So A goes to 2. So just to be a bit smart about this, when we find the first correct answer, what we do is we strike out all the options that do not match our criteria. So from these 5 options that are given to us, we know that options D and E do not match our criteria, so we directly strike them out. So now we are only left with 3 of these options. Now going to the second part, second expression in fact, that says 2 equal to 2 and 2 greater than 3. We know again it's going to be a true and a false, as the previous question had it. But here it's connected, this true and false are connected by an AND operator, which means that a true and a false, if you remember, a 1 and a 0 inadvertently gave us a 0, which means it's going to be a false, which means B is going to map to 3. So B on the left side is going to map to 3 on the right hand side. So that's also correct option. But from these 3 options, you know that all 3 of them, they meet our criteria, because B is 3 for all 3 options. So we haven't made any significant approach there. Anyways, let's see the next one. We know that here it says C, this expression C says 2 is equal to 3. We know that equal to operation is actually an assignment operator, which means that we're going to assign let's say the value 3 to a variable on the LHS, or the left hand side of the equal to sign. But since 2 is not in fact a variable, which means that we cannot assign anything to 2. So that's what we need to understand, that we cannot assign a integer to another integer. We can only assign an integer maybe to a variable. And since 2 is not a variable, it's actually an integer, we cannot assign it, so it's actually an invalid expression. So in that case, your correct answer, your correct option for C would be 1. So it's going to map to 1 on the RHS. Now again, let's go to the options and see. Yeah, all 3 of them have 1, which means that we cannot rule any of them out just yet. Now your option number D, it says 2 plus, that means an integer 2 plus a string value of 2. So it means that we are going to pass 2 as a string value and try to append it to this particular integer 2. But again, you know that you can only do addition operations on like variables. So you can only do it for an integer to an integer or a string to a string. We cannot do it for an integer and a string. So we cannot add both of these expressions together, which means that a 2 as an integer and a 2 as a string cannot be attached, which means that is also an invalid expression. So again, D is going to be mapped to 1. Going back to option, we know that there is only one option that actually meets a criteria, because you know that in this option it says D5 and other option says D4, which means that definitely you cannot choose those 2. So we have already found the correct answer to this question, which is option A, which you can anyway tick. You can anyway use this option as the correct answer, but just to be on the safer side, let's actually see what E says. If the last option is definitely true, then we can choose it. If not, we move on. So E says 2 less than 3. We know that 2 is less than 3, and the output of this particular operator, less than or greater than or equal to operator, is always either true or false. So in this case, since 2 is less than 3, which means your output would be true, which means the expression E would map to 2 on the RHS or the right hand side, which means 2 is also correct. So that means the correct option is already marked for you, that is option A. Now we understood how did we reach till there. Now moving on to question number 39, it says that the given procedure is executed using the library dataset, and we go to the procedure. We see that the procedure name is called selected, and it takes 3 parameters. It takes the author, it takes the number, it takes GEN. Let's find out what all those mean. So we have a variable called count t initialized to 0. We have a variable called count g initialized to 0. Then we iterate through the table. You use a while loop and we read the first row x, that's from the table. Then we say that if x dot author is equal to auth, that is the parameter that we have chosen, or we have in fact inputted this parameter into that particular procedure called selected, and we increment the value of count t by 1. And here we see that because in the first when you parse through this the first time, you may not understand what these variables stand for, auth, gen, num. So what we do is we have to actually read the entire pseudocode. So here auth actually meant it carries the name of the author. Here gen carried the genre of the book. So we increment the value of count g by 1. So you see that it's like a nested loop. So only if the author is the author that we have put in the parameter, only then do we look at the genre. If the genre is also matching, we increment the value of genre, and we move this table, this particular row x to table 2. Then we see that if the count g by count t is greater than or equal to num by 100, then we return true. So what does that mean? Right? Otherwise we return false. And we have put in this particular thing called selected Narayan, that is the author name, the genre is fiction, and number is 10. So this is asking this particular selection that we have chosen, it will return true if, and we have been given the options. So what's happening here is we're going to look at all the books written by Narayan, okay, and every time we see a book that is authored by Narayan, we're going to increment the value of count t by 1, and every time we see a book, a fiction book, or book of the fiction genre written by Narayan, we're going to increment the count g by 1. So you see, we're not incrementing count g every time we see any book. We're only going to see or increment the value of count g every time we see a fiction book written by Narayan. So there you see two conditions. So we see that if count g, so let me just write this for you guys, if count g divided by count, let's say t, that is the value here, if Narayan has written this many amount of count g, and if you divide it by count t, that means it's going to give you a percentage of the fictional books written by Narayan. If you guys can understand, just comprehend this question, because it's basically a fraction, the fraction of books that are fiction to the entire books that are written by Narayan. So that's the fraction that we're counting here, and if that fraction is greater than or equal to 10%. Now why I'm saying 10% is because any number by 100 would give you a sort of a percentage. So if the fraction of fiction written by Narayan is greater than or equal to 10%, then we get true. That's the only time we get true. But if it is less than 10%, that means that we are not going to get true. We're going to get false, because it's not going to enter this if statement. So in that case, what's going to happen is the options read, the first option anyway we know is true, but let's just read the options once. It says at least 10% of the books written by Narayan are in the genre fiction. So as you know that because 10 was the number given here, so num by 100, that is 10 by 100 would give you 10%, and count g by count t would give you the percentage of fiction books, because here the genre is given as fiction, the percentage of fiction books written by Narayan, because count t would give you all the books written by Narayan. Anyways, I'll read the other three options as well. It says at least 10% of the books written by Narayan are in the genre fiction. So pardon me, this is actually at most 10%. So what does at most mean? At most means count g by count t should be lesser than or equal to, let me just write it for you, so it's going to be visually more perceptive for you guys. So this is count g by count t if it was given as lesser than or equal to num by, let's say, 100. In this case, if I had given the value of, let's say, the previous thing, let's say it's selected, it was Narayan, then the other one was fiction, and the last was an integer, that is 10. So in this case, if I had given this selected and I had given this as the condition for true, in that case B would have been the correct answer. Why? Because count G by count T less than or equal to num by 100, which means that the fraction of books that was genre would be at most 10. That means the highest value would be 10 and the other values would be all less than 10%. The highest value would be 10% while the other values would be less than 10%. That is what at most means. So it will be 0 to 10%. That is exactly what at most means. And at least basically means it could be either from 10% to, it could either be from 10% all the way to 100%. This is what at least means in this case. In this case, at least means from 10% to 100%. At most would mean basically 0% to 10%. So that's the difference between at least and at most. So I hope you guys have understood that. Then the option C says at least 10 books written by Narayan are in the fiction genre. Definitely not. We're not counting the number of books, we're counting the fraction of books or the percent of books. So in this case, we are counting percentage. Then the last option says at most 10 books written by Narayan in the genre fiction. Definitely not. We're not counting the number of books, but we're counting the percentage. And in this case, it was at least 10% because in our option it was, let me go to the previous slide. In our option, it was count G by count T is greater than or equal to num by 100. So this greater than or sign means at least. So in that case, the correct answer to question 39 was option A. So with that, let's move to the next question, which is question number 40. So let me clear the screen for you guys before we start. So question number 40 reads, Minisum accepts 3 numbers as parameters and returns the sum of 2 least parameters. Choose the correct code fragment to complete the procedure. So here in this procedure, we can see that there is the name of the procedure is Minisum. It takes 3 parameters A, B and C. And initially we have this variable that is assigned the value 0. Then we say that if A is greater than C and A is greater than B, so this block of code or this particular condition, I should say, means that if both turn out to be true, that is A is greater than C and A is greater than B, it basically means that A is the largest among the 3, which would make C and B, or B and C in fact, the smallest 2 parameters among A, B and C, because A is the largest. So we assign the value of B plus C to sum. Now in the case that it's not true, that is, this if statement does not come out to be true, how else can you write this code, right? So if this is not true, there should be an else statement that says that A is not the greatest. So in that case, we would have an else statement, and then we would go inside the else statement, because we know that if A is not the greatest, then it could either be B or C. So in that case, within the else statement that we have, we should put another if statement so that we can consider the possibility that B is the largest among the 3 parameters, which would mean that B is greater than C and B is greater than A. In that case, A and C would be the least 2 parameters. Now if A is not the largest among the 3, if B is not largest among the 3, so that would automatically mean that C is the largest among the three, and we would not have to put that in a condition because that is the only other possibility. Among the three parameters, either A, B or C could only be the largest among the three. So in the last step, we do not have to put an else or an if statement that says that if C is greater than B and C is greater than A. That's not required because we know that that's the only other possibility amongst these three, which means that sum would be equal to A plus B, which are the least two parameters, because in this third case, C is your largest parameter. So having understood this option, now we can move forward. So let's understand, we know that this is the correct answer for this, right? Because it's already given here, this is the correct answer. But when we go to option B, let's see why is it wrong. So we know that in the first if statement, it says that if B is greater than C and B is greater than A, which means that in this case, B is taken to be the largest and A and C would be the the least two parameters. In that case, then that's also right, okay, because this is a correct statement. Then we go to an else statement that says else you have to increase A plus B. So you see there is an error here. Now we have seen this if statement. We saw that if A is the greatest, so we know it's fine. But then we again check this statement to see if B is the greatest. So if B is the greatest, what do? We increment or we assign the value of sum to A plus C. But as you know that an else statement would be preceding to the if statement, right? The preceding if statement is what is connected to the else statement, which means that if this does not turn out to be true, because our procedure will definitely look at this if statement, then go to this if statement again. It will not skip this if this particular statement is true. Now if it has to go to this if statement, it will definitely again go to the else statement. Now this if statement, which says that B is the largest, if it does not come out to be true, this else statement now has two possibilities. That is, A is the greatest or C is the greatest. So in either of these cases, what it will do is, if B is not the greatest, it will take the sum of A plus B. So if you could understand what I'm trying to say is that in the first case, A was the greatest, okay, but if that is not the case, we would again come to this second statement to see if B is the greatest. And because this second if statement is coupled with this else statement, the else statement will not look that we have skipped over this if statement because A was not the largest. All it will see that is, we know that B is not the largest, so it will automatically take A plus B, even though A was not the greatest or B is the greatest, or in either of the cases it will take A plus B. So in that case, this is not a correct answer. So let me clear the screen here. Now we know why B is wrong. Let's understand why C is wrong. So we see that we have this if statement, but what we do next is we go to an else statement here. So we say that if A is greater than C and A is greater than B, that is if A is the greatest, we take the sum of B plus C. Then we go to the else statement and say that else sum is equal to A plus B. But we know that once we go through this else statement, there is no use of going to another else statement. So we're not going to go to else statements go through else statements consecutively like we go through if statements. So once we see an else statement and it's not true, we directly skip the loop and then come back. Which means that we will not go into the else statement. That means this option is also incorrect because we will not be looking at an opportunity to see if C is the greatest. And we also know that if A is not the greatest in this particular if statement, the else statement considers the possibility that either B or C could be the greatest. So in that case, even if B was the greatest, you go to this else statement and the value of sum would be A plus B, even though B was the greatest, but we would not be looking at the possibility because we will only be looking at C being the greatest. That is the only thing that we're looking at here. So that's why C is also wrong. Now coming to D, we know that there's an if statement here, then we go to this else statement. The else statement, again, it considers the possibility that If A is not the greatest, then this should be for B or C. And again, if B is the greatest of the three elements, we should not be taking it as a sum, with A. So in that case, this option automatically becomes wrong. So because of that, there's only one correct answer for this, that is A, which says that once you have an if statement, we create a nested else statement inside which we have an if and an else. So that is the correct way to write this particular sort of code. So the correct answer, as you can see from this, for question number 40 is option A, and we understood why is it that it's the correct answer and why others are not correct answers. Moving to question number 41. So it says that the given pseudocode is executed using the dataset having the same fields as the words dataset and contains the following words. So this is a tongue twister, so pardon me if I'm not getting this right. So it reads, she sells seashells by the seashore. The seashells are seashells, I'm sure. Oh, I terribly messed that up. Sorry about that. We have this while statement here, and in this particular code, we iterate through the rows 2 times. Why? Because in the first iteration, we're going to get one row X from table 1, and then we move to table 2. So as you know that we have a table called table 1, we have a table called table 2, and we have a table called table 3, and we also have a table called table 4. So we have 4 tables here, and all my words dataset is now in table 1, all the rows. So we could look at the first row X, okay, and then we move that to table 2, and again within that we look at another row Y. This is X and that's Y, and what we do is we read the first row Y from table 1 again, so that is the first and second rows, we are comparing them, and it says that if X dot word is equal to the Y dot word, move Y to table 3. So if they are equal, move to table 3, okay. If they are not equal, move it to table 4. So that is essentially what they are trying to say, that if I find this particular word to be equal to any of the other words, it's going to go to table 3. If it's not equal to any of the words, all those words are going to table 4. So that's what it basically means, right? And then it says move all rows from table 4 to table 1. That means all the rows, okay, all the words that were not equal to your initial X, okay, all those will come back to table 1 and they will again go through the same iteration. So basically what are we trying to do? We're trying to find all the unique words, right? Because it's a simple logic that if the word is equal, we're going to discard the word, we're going to put it into table 3. But if the word is not the same, what we're going to do is we're going to take all those rows and we're going to make sure that it goes to table 2. So that's basically what's happening here. So in that case, we're going to find all the words in this data set that are unique. So the table 2 are going to have all the words that are unique in this particular sentence. So let's see, there is she, that's what we have seen once. So then we have to see if that word she is again coming there. So it comes there. So this particular word would actually go to table 4, okay. And then we find cells. Again, cells is already there here, which means this goes to table 4, table 3. Then this is seashells. We already have a word called seashells here, that again goes to table 3. By the seashore, okay, and yeah, you have seen the again, but we have seen the again, so that means this also goes. Then we have shells. Once we've seen it here, but that's it, and that's all. So you see that we only need to look at how these words come once in the sentence, and then we have shells. Then we have already seen seashells. We have not seen are. We have not seen I am. We have not seen sure. So the final sentence would be she sells seashells by the seashore. And again, you know that shells is a word that we have not seen before. Shells are, I am sure. So that is the final output of this particular procedure, and that is corresponding to your option A, which says that she sells seashells by the seashore. Shells are, I'm sure. So because these are the unique words, because you see that none of the words in this sentence are repeated, and we've not omitted any words that are unique. So all the words that are there in this particular procedure, or pardon me, this particular sentence, are actually all unique, and none of the words that are unique have been omitted. So that is the correct answer, and that is why it is the correct answer to your question number 41. Now moving on to question number 42. So let me clear the screen before we start. Right. So question number 42 reads, a company has collected some data stored in table 1 for promotion of their products. Every row in the table has information about number of people willing to attend the promotion on Saturday and Sunday, respectively, in a given city. For example, take the first row. According to Algebra Book, 20 and 30 people are willing to attend the promotion on Saturday and Sunday, respectively, in Chennai. So this is the table. You can see from here that this is the particular table. Then it says the pseudocode below is used to process the data in this table. So it says, so this procedure has a name called best day. It takes a parameter z. And what we do is we have two variables called count sat and count sun. So from the variable name itself, we can make out that this is going to count the number of people on Saturday and count the number of people on Sunday. And we've initialized both of these to 0. And we say that while table 1 has more rows, so basically we're iterating through this table. And we read the first row x from table 1. We say that if x.city is equal to z, right? So basically now you understood that z, because we rarely are able to understand what these parameters mean in the first time that we go to this table. But as we move through this particular procedure, we will understand that what that particular parameter stands for. So in this case, z is a string variable that is basically the city. So if x.city is equal to z, so here z would mean that we're going to put best day of a city. Let's say this is how the procedure would be if you're running it inside a code. So we would say that best day of let's say Chennai. Since they've given Chennai, I'm just going to write Chennai here. So this is what it's going to be like, and it's going to see if x.city, that is the city column, is corresponding to z. It says that count sat is equal to count sat plus x.saturday. So basically it's going to count the Saturdays, it's going to count the Sundays, and it's going to put it in count sat. And count sun is equal to count sun plus x.sunday. Move x to table 2. And it says if count sun is greater than or equal to count sat, return Sunday. That means if more people attended on Sunday, we're going to return Sunday. Or if not, we just return Saturday, because we know that once we return a value in a procedure, the loop and the entire procedure is terminated right there and then. So in that case, if we were to return Sunday, the entire loop is over. If we did not find any option where Sunday was greater than Saturday, we would automatically return Saturday and the loop is over. So the question is, which of the following is correct? So the options are best day Lucknow is equal to Sunday and best day Chennai is equal to Sunday. So what we're going to do is we're going to go through this entire loop and we're going to see if Lucknow had the best day on Sunday, which is correct because 50 people attended on Sunday and only 30 people attended on Saturday. And in case of Chennai, 30 people attended on Sunday and 20 people attended on a Saturday. So definitely we're going to give Sunday, we're going to return Sunday on both of these days. So this is quite an easy thing, to guess why this first option is correct. But let's see why the other options are not correct. So for option B, it says that best day of Lucknow was Saturday, and we just now saw that on Saturday lesser number of people attended, that is 30 people attended, while on Sunday in Lucknow 50 people attended the promotion. So this is not the correct answer because best day Lucknow would actually return Sunday. Now best day Chennai, they say Sunday, it's correct, but we know that for an option to be correct, both the sub options need to be right too. So in this case, since one is incorrect, we cannot choose this. In option C, we see that best day of Lucknow is Sunday. That's true. And it says best day of Chennai is Saturday. That is not true, because we know that on Saturday only 20 people attended the promotion, but on Sunday 30 people attended the promotion, which means that this should actually be Sunday again. So this is also incorrect. And in option D, we see that both the sub options are wrong, because it says best day of Lucknow is Saturday and best day of Chennai is also Saturday, which are both incorrect. So again, option D is also incorrect. So with this, let's move on to the next question. The next question is question 43. Now it says that the following pseudocode is executed using the words dataset. Now it says that count is 0, and it says while table 1 has more rows, that means we're iterating to the table. We read the first row X in table 1 and then we move that to table 2. Okay, and then what happens is that we have a letter here, and it's L, and we have C initialized to 0, and we have I initialized to 1 and A to false. A is the boolean variable, and we say that while I is lesser than or equal to the letter count, if ith letter of the X dot word is a vowel, if A is letter is equal to ith letter of the X dot word, C is equal to 1. So let's understand this particular thing. So it says that, so in the first if statement, this is a nested if statement. So it says if the ith letter of the X dot vowel is a word, okay, pardon me, X dot word is a vowel, then what it does is that we basically have, let me try to visually represent this. Let's say there's a word like this, and we have now seen this word in a particular row in the table. And in the second while loop, what we do is we are iterating through each of the letters of this word. So that's what is happening. So we see the first letter, we say that if it's a vowel, or if it's not a vowel, we just go to the next loop and we say that, let's see if ith letters of the word is not a vowel, what will happen is, it says that else A is equal to false. That means that the preceding letter was not a vowel, right? This is not a vowel. And then we go to the next one, okay, and we increment the value of I every time we see a word. Why? Because we don't want it to be an infinite loop. So as I increments, it's going to go closer and closer to the letter count, and once we reach the last letter, the value of I is going to be equal to the letter count, and the next iteration what will happen is, once we are done with this letter, the value of I is going to be greater than letter count, which is not going to satisfy this while statement, and we're going to break the loop and go to this if statement. So now let's understand what's happening here. It says that if ith letter of the X dot word is a vowel, and if it is a vowel, what will happen is, if A we know that can only take true or false values. So if A and letter is equal to ith letter of the X dot word. So we know that letter was initialized the value of L, right? And it says that letter is equal to ith letter of the X dot word. And what happens if that is true? What we do is, C is equal to 1, and we assign this ith letter of the X dot word to the variable called letter, and then we give this value of A the value true. So the variable A is going to be assigned the value true, and we're going to go do this all over again. So when is A going to be true is if the previous letter of X dot word R is also a vowel. At the same time, it's the same as the preceding word, or preceding letter, pardon me, it's going to be same as the preceding letter. So let's say in a word called book, right? So we know that this is B, so it's not a vowel, so A is going to be false. But what happens is that here in this case, we have this as O, so it's going to enter this if statement, and what it's going to do is, it's going to put A to true. Okay, it's not going to enter this if statement, it's going to put A to true because it's a vowel. And it's just going to go to the out of the loop, and it's going to assign the letter O to ith that is to the variable letter, it's going to assign the ith letter of the x dot word, that is O. So the second letter of this x dot word is going to be assigned to the variable called letter, right? And what is going to happen now is, now we're going to go to look at the next letter in this word, which is also O. And you see that since both of them are vowels, so here A was true from the last iteration when we saw that O is a vowel, the second letter is a vowel. And then we assigned O to this variable called letter, which means that since both these statements were true, that A was true and letter was equal to the ith letter. Now again, the third letter is also an O and the variable letter is also O. What's going to happen is we're going to enter this if statement and C is equal to 1. So now we found a word who had consecutive vowels, or in fact the consecutive same vowels, and it is occurring at least once, right? Because of that, your correct option was the number of vowels in which, the number of words in which the same vowel occurs consecutively at least once. So you see in this example of book, we had consecutive vowels of the same type. That is, we had two same consecutive vowels, that is O, appearing twice or at least once. So it appeared twice in a row and it happened at least once. So in that case, B is the correct answer for this option. So with that, let's move on to question number 44, which is actually a multiple select question. So what is the question read is, Swara has used a variable max to find the maximum total score using the scores dataset. There are many ways to initialize max. Choose the correct option or options. And it's a multiple select question, right? So how do we choose a variable max? We know that max is something that we need to initialize so that it is not greater than the range of values in which we are checking for the maximum value. So in that case, what we do, let's go through the options. Okay, we know the correct options. I'm going to explain to you how these options are going to make sense to you. So the first option says pick any random card X from the dataset and max is equal to X dot total. So why is this a correct option? Well, we know that there are, let's say, from 0 to 100. Let's look at marks. So 0 to 100 is your range. And we know that any of the cards that we are going to choose as the maximum variable is going to lie within this range, that is 0 to 100. And we know the variable, we know the algorithm how to find out the max value is. Suppose you are checking for physics marks. So it says that if x dot physics is greater than your max, right? You know, this algorithm should be by heart for you guys now. If x dot physics, suppose, is greater than max, then we assign the value of x dot physics, to the variable max. So this is basically the algorithm to find out the maximum value. So now we know that even if we were to choose the maximum marks of the entire data set, suppose we randomly picked out the card X and it was in fact the maximum marks of physics, what would happen is that we would not have to increment max anymore. That's all that would happen. We would just be doing this computation till the end, but max would not improve anymore because it is already the actual maximum value. It's not the correct maximum value. It is the actual maximum value of what we are looking for. Now in case it was not the maximum value, let's say max was the lowest marks, suppose say 40. In that case, we would still be able to increase max. We would just not be looking at any of the values lower than, let's say, 40. Okay, let's say the lowest value was something like 35. Okay, and we got a value of max that is 40. So any card that is below 35, or pardon me, below 40, we would not be incrementing that value, or we would not be assigning that value to max, and we would just be continuing the loop until we found out maybe the maximum marks was 90 in one of the iterations, and we found out that, and that is the maximum value. That's all. So we not have to increment the value at all. Now in the next one, it says pick the top card X from the dataset. Max is equal to X dot total. That's also correct option. Okay, in this case, we just picked a random card and we assigned it. Even the top card, we could do the same way. The top card may or may not be the maximum value. In either case, we would still run the computation and find in the end the maximum value to be the correct value, right? The correct value would be the maximum value because it would not be beyond our range of, let's say, 0 to 100. Then option C says initialize max with any value less than the possible minimum total score. This is exactly what we need to do actually, because we need not always say that max is equal to 0. Why? Because we know that we are incrementing the value of max every time we go through this loop. So even if the total or the highest mark is 100 and initially we assign 100 to max, we know that at one point we would actually come across this 100, and since 100 will not be greater than the maximum, we would not even have to increment the value of 100, but the maximum would be the right maximum marks. So in that case, the value that you've initialized max with would actually be the correct value. And even if you initialize max to 0, in each iteration we would see a physics marks that is greater than max. We would assign that physics marks to max, and in that case we would still get new values, and finally at the end of computation we would get the correct value of max that we can finally give as an output. So in that case we have 3 correct answers here, that is option A, option B and option C. And why is option D incorrect is because we are initializing max with any value greater than the possible maximum score. We know that's not correct. Why? Because then we would have to give an output. Let's say if we take 120 to be the value of max. So we know that there will be no physics marks greater than max, and max at the end of execution would give you a value of 120, even though the marks of the person who scored the maximum number of marks, it would be maybe 99, and the max value would be a value that we do not even have in the range of scores, that is from 0 to 100. So that is definitely an incorrect answer, because the value of x dot physics would never increment, because we know that 99 is not greater than 120, right? This is not correct. So even if we see the maximum marks or the child has scored, it would still be lesser than what value we have initialized max to. So it will not increment, or it will not update the value of max correctly, and max would be 120 at the end of execution, and which would mean that that's an incorrect answer. So because of that, option D is incorrect, and the only correct options are options A, B and C. Now moving on to question number 25, which is also a multiple select question. So it reads, the given pseudocode is executed using the scores dataset. There is a hypothesis that if a student performs well overall, that is scores at least 180 marks, then he or she must have performed well in all the subjects, that is scored at least 60 marks in each subject. At the end of execution, frac true shows the fraction of students who satisfy this hypothesis. Choose the correct code fragments, and it's a multiple select question. So let's go through this pseudocode. So it says count overall is equal to 0 and count per sub is equal to 0, which means that we have these two variables that have been initially given the value of 0. Then we iterate through this table and we read the first row x, and it says that if x dot total is greater than or equal to 180. So now we need to find a segment of code that actually would fill this particular part, suitably. And then we move this x to table 2. Then we say that frac true is equal to count per sub by count overall. So that is the subject marks per subject versus the subject marks overall. So let's go through the options. It's a multiple select question, so they may have more than one correct answer. So the first option says if that is count overall is equal to count overall plus 1. If physics is greater than or equal to 60 and chemistry is greater than or equal to 60 and mathematics is greater than or equal to 60, which means that this person has scored greater than or equal to 60 in all 3 subjects, because it is connected by AND statements. And it says count per sub is equal to count per sub plus 1. So you see from here that in the initial statement we say that if the x dot total is 180, only then do we enter this code fragment. So if the overall marks is greater than 180, we are going to increase the count overall by 1. So this particular variable is being incremented by 1 every time we see that the total marks of the student is greater than 180. Now we have the hypothesis that if they have scored more than 180 in all subject in total, which means that they would have scored more than or equal to 60, greater than or equal to 60 in all 3 subjects individually. So that's how we need to find if that particular hypothesis is true. So in that case, we're going to increment count per sub by 1. So this algorithm is actually correct. This logic is correct, which means that A is also a correct answer. Now move on to B, let's see if B is a correct answer. In this case, we know it is, but let's see why it is the correct answer. So we know that it doesn't matter where you increment a value within an if statement, because once you enter an if statement, you're going to run all the lines. It doesn't matter in which order we run these lines, because as long as the final answer comes out to be true, it doesn't matter. So what we did is, we first went into this if statement. Okay, we said if the x dot total is greater than 180. Now we're saying that another if statement says if x dot physics is greater than or equal to 60, x dot chemistry is greater than or equal to 60, and x dot mathematics is greater than or equal to 60, we increment the per subject count by 1. That means this person has scored greater than or equal to 60 in all 3 subjects, and we're going to increment the count per subject by 1. And once we come out of this if statement, we will anyway increment the count overall variable by 1, because we know that if we enter the if statement, that was the main if statement right here, that is if x dot total is greater than or equal to 180, we know that we're going to have to run this line anyways. So we increment the value of count overall by 1. It doesn't matter if we do it before the nested if statement or if we do it after it. So that's not an issue. So in that case, this option is also correct. B is also, that's why B is correct, because it doesn't matter the order in which we run these lines. Now we know that if x dot physics is greater than or equal to 60, x dot chemistry is greater than or equal to 60, and x dot mathematics is greater than or equal to 60, we have to increment the count per subject, because it is the count of the individual subjects. But here what we do is, we even increment the overall count by 1 inside the nested if statement, which was supposed to count the individual subject scores. So in this case, this is incorrect, because we are incrementing both these variables inside the nested if statement, which is not correct, because count overall is to be incremented in the outer loop, that is the outer if statement. So in that case, C was not correct, because it was an incorrect way of incrementing count overall. Now in option D, it says that if x dot physics is greater than or equal to 60, x dot, or basically I'm going to just say that if all 3 subjects this person has scored greater than or equal to 60, we are now incrementing count overall by 1 instead of the per subject count. So in that case, what would happen is that our fraction would be the opposite. It would be an inverse of a fraction, because we know that we are counting the fraction by saying that count per sub, this variable count per sub divided by count overall. So basically what's going to happen is, if we were to do it in this way, what is given to us in option D, we would actually be getting an inverted fraction, which means that the numerator would go to the denominator and the denominator come in the numerator, which would mean that we will get an inverse fraction. So that is not the correct answer. So that's why options C and D are incorrect, and the correct options to question number 45 are options A and options B. Now moving on to question number 46, it's also a multiple select question, right? The question reads, the following pseudocode is executed using the words dataset. At the end of execution, count stores the number of pairs of consecutive words which have equal number of vowels. Choose the correct option or options, and it's a multiple select question. Now in the pseudocode, we have this variable called count that has been assigned the value of 0. Then we say that while table 1 has at least 2 rows. Okay, so previously we were always checking if table 1 has at least 1 row, but in this case we want table 1 to have at least 2 rows. Then we read the first row x from table 1, and now we have a variable called count vx, and it is being assigned the return value of a procedure called count something. And count something, from here we can say that it takes the parameter as the row in this table, because we know that x is a row and it has taken a row as a parameter. Now before we proceed, we need to know what is the return value of count and what is it counting, right? So let's go into the procedure. So the procedure says count something and it takes a parameter z from the code, pseudocode. We know that it's actually the row. Now we say that I is equal to 1 and a is equal to 0. So we have two variables I and a, and I has been initialized to 1, a to 0. And it says that while I is less than or equal to z dot letter count, so that means when first in the table we were iterating through the words. Now within the word we are iterating through the letters of the word. So that's what's happening right now. It says that if ith letter of the z dot word is a vowel, then increment a by 1 and return a. So basically we are counting the number of vowels. So that's a very simple procedure right now, because we know that when we iterate through the letters, we're just going to check if that letter that we have seen right now, if it's a vowel, we're going to increment the value of a. So that's quite easy, and then we return a. So count vx would just give you the count of the number of vowels. Then it says move x to table 2 and read the first row y from table 1 and count vy. So now again we count vy would have the number of vowels in the next word. So we saw the first word, we assigned it x, we saw the next word, we assigned it y, and now what we do is we have these two words in the same while loop. That's why we needed at least 2 rows, because if there are only the last row left in this particular table, then we would have a row x, but we would not have any other row called y. This would not be possible. So in that case, we need at least 2 rows, so that within the same iteration of while loop, we're going to go through the entire table. Now we say that if vx is equal to vy, count is equal to count plus 1. So now we need to know that what does count represent. So from here we know that it only is going to be equal if it has 2 vowels in the same this one. Okay, so what we're going to do is we're going to go through the options, right? We're going to go through the options. We're going to see which one is correct. So option A says the above pseudocode will not provide the correct result because table 2 must be restored to table 1. So look at the question. The question says at the end of execution, count stores the number of pairs of consecutive words which have equal number of vowels. So we know that we want to look at consecutive words. It does not say if this particular word, how many words does it have consecutive or it does have the same number of vowels with, right? Only in that case we would have to restore from table 2 to table 1, so that we compare one word with all the words. So that's not the reason here. We just want to find the number of consecutive words which have the same number of vowels. So in that case, this option A is not correct. Option B says the above pseudocode will not provide the correct result because y is not being moved to anywhere. So again, that is not correct, because you know that here in the number of words, we look at these 2 words, we move x to another row, so that we can now look at these 2 particular words, so that this y in the next iteration becomes your x and this becomes y, and in the next iteration we're going to go like this. So this now becomes your new x and this becomes your new y. So like that we're going to look at consecutive words. That means we are not supposed to move your y somewhere, we just have to move the x. After every second iteration we're going to move the x, so that we make the y in the next iteration as x, and the succeeding word to it we're going to make it y. So in that case what's going to happen is that we're going to count how many consecutive words have the same number of vowels. So that's why B is also incorrect, right? Now A and B are incorrect. Let's see why C is incorrect. It says the above pseudocode will not provide the correct result because the last word is not being compared. That is not true. We know that in the second last iteration, or in the last iteration, in fact, the second last word is going to be your x and the last word is going to be y. That's all. So we have compared y with the second last word. So the last word and the second last word are being compared, and then x is going to move, and then this table 1 is only going to have 1 row, right? In the last iteration it's not going to iterate it because we need table 1 to have at least 2 rows. That's all. But in the previous iteration we have compared the second last and the last row. So This is also incorrect. So the only correct answer to this multiple select question is option D, which says the above pseudocode will provide the correct result, because it is providing the correct result, because we are doing everything possible so that we are not missing out on any of these comparisons of consecutive words in this particular data set. So therefore we have found the correct answer to question number 46. So let me clear the screen right now. Right. So with that, let's move on to question number 47. So the question reads, the following pseudocode is executed using the shopping bills dataset. At the end of execution, A captures the highest price of an item purchased from Big Bazaar. But the pseudocode may have mistakes in one or more lines. Identify all such lines, if any. Assume that all statements not listed in the options below are free of errors. So let's actually go through the pseudocode once. So it says that first we initialize the variable a to 0. Oh, pardon me, let me just, yeah. So we have initialized the variable a to 0 and we iterate to the list. In fact we are iterating to the pile, and we say that while pile 1 has more cards, read the top card x on pile 1, and if x.shopName is equal to Big Bazaar, temp is equal to find item of x, and we know that here x is the row, the parameter that is taken in this procedure is actually the row or the card that we have in our hand right now, and if temp is greater than a is equal to temp. So this algorithm we already know from our previous discussion that this is the correct algorithm to find out the maximum. Right, maximum of any value, and in this case a is what stores the maximum value. And then we move this card x to pile 2. Now we have to go through this procedure find item, which takes a parameter y, and we know from the pseudocode that y is actually the row or the card. In fact, in this case it is the card that has the shopping bills dataset. And we see that in the procedure, first thing what we do is we initialize this variable max price to 0. And we say that while card y has more items, right? So we have a particular pile which has all the cards, and each card, as you know, actually has which all items have been purchased, right? Along with the name of the customer, the name of the shop, the customer ID. So along with all these things, you also have the items purchased, the quantity, the price. We also have a column that has, or a variable that has the total of the entire bill. So these are the things that are there on the shopping bills card. And we say that while card y has more items, so we iterate to the card now. It says read an item z from the item list of card y. So read an item z. So we are going to go through the first item. It says that if max price is greater than or equal to z max price. So which means that it says that while this item z, okay, if its max price is greater than or equal to the z dot max price, then max price is equal to z. So we don't want it to have greater than or equal to, right? We want it to be the highest. So only if the max price is highest than the current price, only then can we find out the maximum, because we know that that's the incorrect algorithm, because to find out the maximum it should always be that if the current value is greater than the variable that stores the maximum value, only then do you assign the value of the current variable to the maximum variable. So in that case what happens is that in this case in fact your max price is greater than or equal to the z dot price, and that equal to sign is what is causing the error. So line number 16 is what has the error. Then we say that remove z from item list of card y. Why? Because now we are done with that item, and then we return max price. Once this entire while loop is completed, we return max price, and that is what is going to go into the variable temp here. Right here it's going to go into temp, and we see that if temp is greater than a. So after reading this entire pseudocode, we only know that there is an error in one line, that is line 16, and that is consistent with the options, which says that line 16 is the only line that has an error because it is an incorrect conditional statement, because we know that we do not want max price to be greater than or equal to the current price. We want the max price to be only greater than the z dot price. So in this case, your correct answer to question number 47 was option C. Now the next 4 questions are of comprehension type. So anyways, let's go through these questions, right? So let's read the question. It says the given pseudocode is executed using a dataset having the same fields as words dataset and contains the following words. So this is the paragraph. It says Iit Madras has launched the world's first ever online degree and diploma courses in programming and data science. Anyone who has passed class 12th examination can enroll in the online course. There are 3 levels in the degree program. There are a total of 31 courses. The completion time is in between 3 to 6 years. Learners will have to complete the online course, assignments, quizzes and exams to gain 116 credits. The online application process for the new batch is open now. And it says that assume while moving the rows from one table to another, the rows are always arranged in the increasing order of sequence number from top to bottom. So basically it means that the integrity of this data set is maintained. So this means that the words will not get jumbled, and we are going to give a unique sequence number to each of these words, because of which this entire data set is going to be in the correct order that has been given. So we have the pseudocode in which we have 2 variables count and I initialized to 0. We iterate through this table 1 and we read the first row x from table 1, and it says that if I is equal to 0, then we move x to table 2 and we give the value 1 to I. So we assign 1 to the variable I. If I is not equal to 0, what do? We move x to table 3. And we say that if x dot word ends with full stop, I is equal to 0, right? So what basically happens here, because the first word of that particular sentence is going to anyway have I is equal to 0, so that's going to go to table 2 and we're going to initialize I to 1. And from the next word onwards, we're going to move x to table 3. Till when? Till x dot word ends with a full stop. So the first word in this particular sentence, in fact, which would be this entire sentence, the first word, the I would be 0 for that, right? Because we have not changed the value of I. And what happens is we then put this particular word to table 2. And then we initialize or we assign the value of 1 to I. And from the second word onwards, since the value of I is not 0, that means it is 1, we move the second word onwards, all the words, we're going to move it to table 3 until we find the word with a full stop, right? Till the word we find it with a full stop, we're going to go to table 3. And once we reach table 3, what we're going to do is we're going to initialize I back to 0. So the first word of the next sentence is again going to go to table 2. So I hope you understand this logic. That's what this particular pseudocode is trying to tell us. So with this understanding, we know that table 2 is now going to have the first word of every sentence, and table 3 is going to have the rest of the words of the sentence until the last word. So with that, let's go to the 48th question. So the question reads, choose the set of correct words in table 2. So how to do this? Well, basically go back to the previous slide, read the comprehension and read all the first letters, because we know that table 2 is going to have the first letter of each and every sentence. So read the first letter of each and every sentence. So the first sentence has the first word as IIT. The next word is anyone. The next word is there. The next word is again there. Then the next word is the. Then there is learners. And there is the. So having seen that, we know that option A is correct. Why? Because it's IIT, anyone, there, the, learners, the. So these are all the first words of the sentences in our data set, which means that option A is correct. And I don't think I have to explain why options B, C and D are wrong, because we know that these are not all the first words of the sentence. So that's why all the rest of the options are wrong. And since it's a multiple select, if it's a multiple choice question, there can only be one correct answer. And since we have found the correct answer, we do not have to look further. So going to question number 49, it's also a multiple choice question, and it reads, consider the table 2 created from the previous question paper. At the end of execution, what will the value of count max and occur max be? Right? So count max in the pseudocode and occur max. So count max is an integer variable that stores 0 initially. Occur max is a string variable which stores the value of none. Then it says while table 2 has more rows, so we are iterating through table 2 now. Now we know that table 2 has only these many words, that is 1, 2, 3, 4, 5, 6 and 7. So it has exactly 7 words. So this in fact is your table 2 after the execution of that particular paragraph that we had in the comprehension. And we're going to go through this table 2 and we're going to iterate through it, and we're going to say that we're going to have this count, a variable called count, and we're going to assign 0 to it, and we read the first row y from table 2. So in this case, first row would be IIT, that is the first word of this row, and it says that move y to table 4. So in this case, now we have moved y to table 4. Now what we do is we say that while table 2 has more rows, so now we're going to go through the rest of this entire rows, and we say that read the first row z from table 2. So now z is going to be from these words that are there now, from any1 to the, and it says that if if y dot word is equal to the z dot word, count is equal to count plus 1. So it basically means that if you have 2 consecutive words, right? My bad, it's not 2 consecutive words. If you have 2 words that are same in this table 2, we're going to increment the value of count by 1, and we're going to move z to table 2. So which means that now z is going to go to table 4. Okay, if anyone was same as IIT, it's going to go to table 4, else it's not going to go. And in that case, if the y dot word is not equal to z dot word, then we move z to table 5, right? So this is not equal to anyone is not equal to IIT, so we're going to move it to table 5, and similarly there are no other words. So, and then we say that we move all rows from table 5 to table 2, which means that if we find a word that is same as another word, right? If we find any word that is same as whatever word we have seen, that means we're going to move it to table 4. Otherwise, we're going to move to table 5, and then we are going to go through all the rows, all the unique words that we have found out. We're going to compare them again to see if there are any other words that are similar to it. So all the unique words go to table 4. If you don't find any unique words, what it does is it goes to table 5. And then we say that if count is greater than or equal to count max is equal to count, and occur max is equal to y dot word. So this is a very cliched algorithm. We know that this basically means that we're trying to find out the maximum value, and in this case count max would store the maximum occurring word, okay, the count of the maximum occurring word, and occur max will store the string value of the word that is occurring the maximum. So in this case, let me just clear the screen for you guys. So in this case, from this particular set of options, we know that there are 2 words, right, that are occurring the maximum, that is there and the. But since we are going through these set of words one by one, that is we are going through them in order, so we know that we would update the count 2 for maximum, right? We can update count 2 for maximum. But since, if you guys see that this algorithm for maximum actually has a greater than or equal to sign, so in the first loop or the first iteration, we're going to find that count max is going to be 2 because there are two values for there. But in a subsequent iteration, we're going to find that even the word the also has two occurrences, and these two occurrences mean that it is going to be equal to the current value of count, which means that count max is going to be equal to count. So which means that we're going to assign the value of count, which is the number of occurrences of the, and we're going to say that occur max is equal to y dot word, which is also the, because in the latest iteration of the word, we found that the is what has the count value equal to count max. So count max is already 2 because it was for there, and now the is also count, or is also the greatest or equal to the greatest, which means that it's also the same. So in this case, what would happen is that even though there and the both have the same number of occurrences and same number of counts that are happening in the sentence, but since we have chosen this algorithm which says greater than or equal to, so it's going to find the latest occurrence of the word. So which means that the was the word that has the latest occurrence of 2, which was equal to there, but it is the latest. So that is what is going to have the maximum value count, that is 2 occurrences, and the word is the. So that is why B is the correct answer. So having seen that, we're going to move on to the next comprehension type question, which is valid for questions 50 and 51. So question 50, so let's read the comprehension first. It says the following pseudocode is executed using the library dataset. Assume that an author publishes at least 2 books and only 1 in a year. So that means an author can have 2 or greater than 2 books, but this author only has published 1 book in a year. So in the pseudocode, we see that we have initialized the value of count to 0, max to 0. Then we say that we are going to go through this table 1. We're going to iterate through this table. We read the first row X from table 1 and then move that particular row to table 2. Then we again, you know this particular procedure by now, that if we have 2 nested while loops, we are comparing a single author with all the authors, for each of them authors. Then we say that we read the first row Y from table 1, and then we say that if X dot author is equal to the Y dot author, we move row Y to table 2, else we move row Y to table 3. So basically, if 2 cards have same authors, or 2 of the books have the same author, we're going to move that particular table or that particular row to table 2. If we do not find 2 books with the same authors, we move all those rows with different authors to table 3. Then we have this variable called diff, and it is assigned the return value of a procedure called do something, which takes its parameter as table 2, as we can see from here. So before moving forward, we need to know what is the return value of do something. So for that, we need to go through this procedure. So the procedure takes table 2 as one of its parameters, or as its only parameter, and we say that A is equal to 2050, B is equal to 2050. So we have assigned what I'm assuming is the year, right, or what is the latest year, and because we have not seen 250 yet, so we're going to assume that we're going to find the minimum year, because we know that to find out the minimum value, we can take any large value that is out of your scope, so that the first value that we see within our range is going to be lesser than what is the current value. Anyways, let's see what's they got offer here. They say that while table 2 has more rows, you read the first row Z from table 2, and if Z dot year is less than A, B is equal to A, right? So it says that if your Z dot year, that is the year that you're seeing in your card right now, if it is less than A, which was 2050 here, then you assign this particular A to B, and to A you're going to assign the Z dot year. So A, as you know, as you can see, is going to have the minimum year, because we know that if any minimum value, right, let me just write it for you. Let's say if year, okay, let's just take this example. If this year is lesser than a minimum value, okay, it's an if statement. because it's lesser than the minimum value, you're going to assign that year to the minimum value, so you get the least year. So you know that this particular algorithm, you know, is to find out the minimum value. So here the minimum value has been replaced by a, which is the same thing, because a is going to count your minimum value. But why have we assigned this value of a to b before assigning the value of z dot year to a? That's because we want b to have the second minimum year. So the value of just before a, or the just preceding year to the minimum, would be the second minimum, second least. So in that case, it says if z dot year is greater than a and z dot year is less than b, then b is equal to z dot year. So if the value of b was not the same, right? If the value of b dot year was not lesser than the minimum value, what we would do is we're going to go through this if statement and see if the z dot year is greater than a. That means the book was published after your year, but it was before the b. Suppose, let's say there was a book published in 2001, right? And that is your minimum or the least year, okay? And this is what it says. And the value of a before this was 2000 and let's say 3. But there was a book that was published in 2002. But now the value of a is 2001, value of b is 2003, but you want b to have the second minimum year, which would be 2002. So that is why we are going through this if statement to say that if, this if statement to say that if z dot year is greater than a and z dot year is less than b, then your b would be equal to z dot year. And then you move that row to table 4. And then you return b minus a. So b minus a would basically give you the difference between the minimum year and the second minimum year, right? So if 2002 and 2003 were the two least years, right? In that case, your b minus a would be 1, which means that there is a gap of 1 year. So from this itself, we should be able to understand that a gap of 1 year means that this author took a gap of 1 year before publishing 2 of his books. Then it says that if diff, that is difference, let's just call it what it means, the difference between the 2 years is equal to max, then count is equal to count plus 1. If the difference is greater than max, max is equal to difference and count is equal to 1. So we understood that because you have this gap, that there is a gap in the years that this person is selling or is writing his books, which means that in this case and in this particular case, we want to find out the maximum gap that an author has had between publishing 2 books, right? So because of that, the correct answer, as you can see from the options, is that option A says the difference between year of publication of first and second book of the same author. So that is what do something is doing here. We already know that do something, what is it doing? It is basically finding out the difference in years. So as I told you, if there are 2 years and author B and author A have the same book, okay, and if 2 books have the same author, that means this particular author has 2 books, and if there is a difference of say 1 year, so this is what do something is going to actually find out, the difference in the years of subsequent publication of books. And that is the correct answer for what will the procedure do something return. And the final question of this particular qualifier, that is question number 51, would say that what will count represent at the end of execution? We know that count would basically be checking the maximum gap between the year of publication of the first and second book. So that means, let's say if an author has a book published in 2000 and the second author has published his or her book, let's say in 2010, so the gap here would be 10 years. Now let's say there is another author, author B, who has published their book in 2000, let's say 3, and the next book in 2013. This gap would also be 10 years, which means that the value of count would actually be incremented to 2, because you have 2 different authors, okay? Mind you that these 2 are different authors who have published their books in totally different timelines, But the thing is that they both have the same gap of 10 years between publishing book 1 and book 2. So count would basically count the number of authors with the maximum number of or the maximum gap between the year of publications. So now let's say we found another author, author C, who had their first book published in 2000 and the next book published in 2013. Okay, I'm just taking these examples. Okay, you can choose any number of your choice. Now you see that now there is only one author with this maximum gap of 13. So their count would actually be again assigned the value of 1, as you can see from this particular line. Because if you find a difference that is greater than the current maximum, we again assign the value 1 to count. So as you saw from here that the correct answer would be that count would be counting the number of authors with the maximum gap between the year of publication of the first and second book, which corresponds to option A. So with that, learners, we have come to the end of the qualifier paper, the mock exam, as you can say for now, because now we have understood why any question is coming out to what it is, right? Why any of these answers are coming out to why they are, and because of this, we need to learn, we need to revise, we need to practice these question papers, because these question papers are a great source of your understanding. And for that, I think you guys need to learn as much as you can, get to the understanding, get to the concepts, because don't try to mug up these things, don't try to mug up the questions and the answers, because it's very rare that the same questions are going to be repeated. All you need to do is understand the concepts, and if you understand the concepts, this thing becomes a lot easier than what you can even expect. So with that, we are done with these qualifiers, and hope you guys have prepared quite well, and all the best to all the learners. Thank you, learners.